So that's what we were discussing before the last video ends, which is the formation of the ionic bond. And we were saying that in this example here, you have seen that sodium is giving one electron to chlorine. So sodium is transforming into a sodium ion, a positive sodium ion, and the chlorine is transforming into a negative chloride ion. Okay, so because positive and negative attract, so this electrostatic attraction between sodium and chloride ion is called an ionic bond, and it leads to the formation of sodium chloride compound, which is the table salt that we're putting on our food. So let's watch the formation of these ionic compounds. So we will see this here. So
a small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
So you have seen here the formation of this sodium chloride, and it is an explosive reaction. So as you can see, it releases a large amount of heat. Okay, so this is what is happening. Sodium giving an electron to chlorine, and these two ions are formed, and when these two ions are formed, they stick together, forming sodium chloride compound. Another thing, which is the formation of magnesium oxide, and this is another compound that is formed between a metal and a non-metal, and of course the type of this compound is also an ionic compound. So let's see what's happening here. So this is the formation of magnesium chloride, and magnesium chloride, it ignites with a white flame, and I will try to show it to you in another slide. Okay, but actually what is happening is what's here on the right of the slide, which is that magnesium has two electrons in its outermost. It's a metal, so it loses electrons, and these two electrons are transferred to the oxygen, which is a non-metal and needs two electrons to fulfill the octet rule and to have 8 electrons in its outermost. So magnesium is transformed into a magnesium ion, and oxygen also is transformed into an oxide ion, and this one is positive, this one is negative. They both attract, forming magnesium oxide, which is an ionic compound. So these were two examples, yes, and this is how it works. This is the reaction. You see the bright white flame that comes from this the reaction of magnesium, okay, with oxygen. Yeah, okay, so we're done with that. So generally speaking, ionic bonds or ionic compounds, they are formed between a metal and a non-metal. Okay, and again, ionic bond is an electrostatic attraction between ions that are oppositely charged, a positive and a negative ion. Okay, and we of course know that ions, they come from the loss or gain of electrons. Okay, so let's try to name ionic compounds. So we will start by the naming of ionic compound. And we have seen before that whenever we're talking about a metal ion, the name does not change. So if sodium forms an ion, that's a sodium ion. If potassium forms an ion, that's a potassium ion. But for non-metal ion, whenever we're discussing non-metal ions, we have to add the suffix "ide", and this is what we said before. So if sodium and chlorine are going to react together to form an ionic compound, the ionic compound name will be sodium chloride. So we have to add the suffix "ide" to the non-metal. So let's look at here and try to do this exercise. Pause the video and return back when you finish. And we're back, and and here are the names of the different ionic compounds formed from these metals and non-metals. So that's gonna be sodium nitrite, lithium oxide, aluminum sulfide, cesium phosphide, strontium fluoride. So it's really important that you have to know that non-metals, they change whenever you are trying to put them in an ionic compound and they form ions. Also, let's try to do this. Pause the video and try to use the periodic table to identify the symbols for both the metal and the non-metal and try to name these compounds. And we're back, and these are the names, yes, of these ionic compounds. Okay, easy, right? But we have seen here that some of these ionic compounds, we don't just stick the symbol of the metal next to the symbol of the non-metal. If this is true for these three examples, we're just putting calcium symbol next to oxygen symbol, zinc symbol next to sulfur symbol. Yes, but this is not the rule, because we see here that we have here what we call a subscript, and a subscript would tell you the number of atoms or the number of ions that are in this formula. For instance, in this lithium nitride, we have 3 ions of lithium and just 1 ion of nitrogen. So why is that, and how is it possible for us to predict the formula of ionic compound? Because it seems that we don't just stick the symbols together. Okay, so let's see how we will do this. So usually what you do is something called the crisscross method, and the crisscross method is really easy, but let's, for instance, try to figure out why do we have to do this. Actually, you have seen before that there are some electrons that are lost from the metal and some electrons that are gained from the non-metal. These two the number of electrons should be equal in both cases. I mean that the number of electrons lost should be equal to the number of electrons gained. Okay, because electrons, they cannot just swim in space. Someone has to take them. Whenever they are lost, they have to be taken by a certain atom. Okay, so you have to make it you have to make sure that the number of electrons lost is equal to the number of electrons gained, and for that reason, that's why we're doing this crisscross method. So actually, the crisscross is very easy. Relying on the periodic table that we have done before, which will show you the charges of the different metals and non-metals, that one I will return back and show you this table that we were using here. Depending on the location of the metal and the non-metal, you can see the charge, okay, of the ion. So we will start by putting the symbol of the metal and the charge underneath it, and the symbol of the non-metal and also its charge underneath it. And when we're done, we are going to do a crisscross. So let's see it again. Okay, yes, okay. So, and then we're gonna switch the numbers. So let's do an example. So here, when he's saying the write the chemical formula of potassium iodide, we will have to find the charge first of each ion. So potassium is a +1, iodine is a +1. So we're trying to find the ratio between both. Okay, so this is potassium, this is iodine, and potassium ion has a charge of +1. Iodide ion has a charge of -1, and we're gonna do the crisscross, and the symbol will be only potassium iodide. That's a ratio. Actually, it's a ratio between different ions in a certain formula. So let's return back again to this example here. We have aluminum, and aluminum is in group 3. If you return back to the table, you will find that it has a charge of +3. And nitrogen, the nitride ion, has a -3. And we're gonna just switch the numbers. So instead of saying Al3N3, we're gonna take the simplest ratio, and 3 to 3 is 1 to 1, and we're gonna say ALN. Okay, right. Let's check another one. I don't know why is it moving that fast. Okay, so let's check this one here. So potassium oxide. So we're gonna go and look for potassium in the periodic table, oxygen also in the periodic table. We will find that potassium is in group 1, so this means it has a +1 charge. Oxygen is in group 6, it has a -2 charge, and we're gonna do the crisscross, and K will have a 2 next to it, and oxygen will have only a 1, so that's the symbol for potassium oxide. And a ratio of what? The ratio of electrons that are lost or gained. So in order to understand this more clearly, let's look at the electronic configuration of both atoms. So this is the electronic configuration of potassium, and this is for oxygen. So it's a 2, 6. So you can see that potassium can only lose, each potassium atom can only lose 1 electron, and oxygen can gain 2 electrons. So actually oxygen, it cannot take only this 1 electron from potassium, because this is not gonna make oxygen stable. So oxygen needs 2 electrons. So in order for oxygen to react with potassium, 2 potassium atoms should be there. 2 potassium atoms should be there. Because when 2 potassium atoms are there, you have 2 electrons, one from this potassium atom and one from this potassium atom. And when these 2 potassium atoms, when these 2 electrons, they are gained by oxygen, and oxygen will achieve a stable electronic configuration with 8 electrons in the outermost, and this is gonna be the oxide ion. Okay, tamam. So that's why you will find K2O. So K2O means that each oxygen atom needs 2 potassium atom. Each oxygen, because it needs 2 electrons, so it needs 2 potassium. So that's the ratio with which these 2 atoms react, or these 2 elements react. So oxygen, when it reacts with potassium, it will react in a ratio of 2 to 1. 2 potassium and 1 oxygen, and that's why this is the formula of potassium oxide. I hope that you could be able to get this. And let's return back again. So now we're gonna discuss an important thing, which is some of the metals, which are the metals, the transition elements, they can have more than 1 charge. Meaning that you cannot predict their charge. They may have a +1, sometimes a +2. Some of them may reach a +7. Okay, so they can lose up to 5 electrons and 7 electrons sometimes. Okay, so that's really interesting because they are different from the other metals. So this applies only on the transition metals. So whenever you have a transition metal in a certain formula, it is hard to write this formula unless you know how many electrons this metals will lose. So that's why usually in this type of formulas, you are given the number of electrons that is lost by each atom. For instance, in copper 1 fluoride, the 1 here means that the copper has a charge of +1, means that it has lost only 1 electron. Here copper 2 means that copper has a +2, copper 2 again, and copper 2 again and again. Okay, so whenever you're writing a formula for these compounds, you will have to make sure that you interpret the Roman letter between brackets into the charge of the elements before it, which is a transition element. So when you go to the next video, you will find how we will do these formulas.